Okay, section 7.4 is called Solving Quadratic Equations. We're going to do this in 2 days, so 2 videos. And now I'm going to switch to a Pre-Calculus 11 video to do the next 10 minutes for me. So I'm sorry about the bad edit. It's going to look a little bit different, and the title's going to change here, but deal with it. Here we go. So if you look here, we have something that looks a lot like general form of a quadratic function, right? If this was a y right here, that'd be general form of a quadratic function. Well, guess what this is? This is general form of a quadratic equation. Remember the difference between a quadratic equation and quadratic function is that the quadratic equation equals 0 and you're trying to solve for the x's. So if you have a quadratic equation but b equals 0, then you can actually solve it by using square roots. So first of all, if b equals 0 in this general form of the quadratic equation, what would you have left? You'd have ax squared plus 0x, well, you don't need to put 0x's, it's not there, plus c equals 0. So if you have something in that form, ax squared plus c equals 0, then you can solve by using square roots. Now, you don't always have to, so we're going to do some examples here. And the first example, you can solve either way. You could solve the factor method, which we did last time by factoring, or you could do the square root method, which we're going to talk about today. So let's do it both ways. So for the factor method, the factoring, what we did last time, what we said you always had to do is you wanted to make it equal to 0. So let's move this 14 over. Remember, we want to keep the x squared positive, so we're going to subtract 14 from both sides. And that leaves us with x squared minus 9 equals 0. And then our strategy is with the factoring method is once we have it equal to 0, we want to factor. Can you factor this side? Yes, you can. This is a difference of squares, right? This is going to look like this. What multiplies by itself to get x squared? X and x. What multiplies by itself to get 9? 3 and 3. Since there's only two terms, one term has to be plus, one has to be minus, so that the middle term will cancel. Anyway, we've done that a whole bunch of times. I'm not going to do it again. Alright, so now we use the zero product property. If this factor times this factor equals 0, then either the first factor, x plus 3, equals 0, or the second factor, x minus 3, equals 0. And then we can solve each one of these little equations. If you subtract 3 from both sides here, you get x equals negative 3. If you add 3 to both sides here, you get x equals positive 3. So your answers are 3 and negative 3. Great, now let's solve it a different way. Let's solve it using the square root method, sorry. So there's two steps with the square root method. One is to isolate the squared part of the equation, and the second part is to take the square root of both sides. So the squared part of this equation is right here, right? That's the squared part, the x squared. So we want to isolate that. We want to get it by itself. Well, that's pretty easy. All we have to do is subtract 5, and we'll have the squared part all by itself. So we're left with x squared equals 14 take away 5 is 9. Now, we've already done this before as well in a previous chapter. If you're solving this, you want to get the x by itself, isolate the x. So since it's squared, you do the opposite of squared, which is square root. So you take the square root of this side, and you take the square root of this side. But remember, when you're solving an equation by taking square roots, you need to put plus or minus there. I'll talk about that more in a second. So the square root of x squared is just x. We did it. We got x by itself. And the square root of 9 is 3. So you get plus or minus 3. That's your answer. If you compare plus and minus 3 to this, here you have minus 3 and positive 3. Well, that's the same as plus and minus 3. So these answers are exactly the same. It worked. You can use the factoring method. You can use the square root method. Square root method is a little bit faster, wasn't it? The plus minus, remember, if you're solving an equation, if I'm asking myself, what can I square, what number, if I square it, do I get 9? 3 works. 3 squared is 9. But negative 3 also works. Negative 3 squared is also 9. But if I just asked you this, right, if I just said evaluate that, what would you say it is? 3. It's only when you're solving equations that you have to use the plus minus. Alright, a little review for there. Okay, next one, we're going to try to solve this by factoring. So to solve by factoring, we want to make it equal to 0. So let's move the 20 over. So x minus 4 squared minus 20 equals 0. Oh, you know what we're going to have to do now? You're going to have to do, you're going to have to expand this. So x minus 4 squared is the same as x minus 4 times x minus 4. Then you're going to take away 20, and it equals 0. All right, mountains and valleys now on this side. Here, 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 and here. So you get x times x is x squared. X times negative 4 is negative 4x. And negative 4 times x is another negative 4x. So negative 4x plus another negative 4x is negative 8x. Negative 4 times negative 4 is positive 16. And then we have a minus 20. Combine these two terms here, you get x squared minus 8x minus 4 equals 0. And now we're ready to factor. So to factor this, we're looking for two numbers that multiply to 4 and subtract to 8. What? Multiply to 4. The only numbers that multiply to 4 are 1 and 4 and 2 and 2. And they have to subtract to 8? It doesn't work. Oh no. We can't do this. This is why the factoring method won't always work. If you got to this point, what you would have to use, or you could use, is the quadratic formula, which we haven't learned yet. So we'll learn the quadratic formula another time, but we're stuck here. Stuck. We can't do anything. So let's see how we could do the same thing by using the square root method. This is going to be much easier, and it's actually going to work. So the first thing it says to do is isolate the squared part. What's the squared part here? All of this is the squared part. So we got to get that by itself. Well, it's already isolated, right? So we can go straight to our next step, which is to take the square root of both sides. We're going to take the square root of this side and the square root of this side, and when we take the square root, we better put plus minus. Okay, so what we have on this side is just x minus 4. The square root of x minus 4 squared is just x minus 4. And what we have on this side is plus or minus root 20. Want to get that x by itself, so we better move that 4 over. Got to add 4 to both sides. Now, when you add 4 to this side, you can't add it here and get 24, right? This is in a radical sign. So I'm going to put the 4 first. 4 plus or minus root 20. You don't have to. You could put plus or minus root 20 plus 4, but I think this looks a little nicer. And that's pretty good. There is one thing I'd love for you to do, though. I'd love you to simplify this radical here if possible. Remember how to simplify radicals? Here's where you make that tree. We did a whole bunch of this last year. Make a tree. Any two numbers that multiplies to give 20, except 1 and 20. How about 10 and 2? Any two numbers that multiply to get 10. How about 5 and 2? These are all prime numbers, so we're done. Since it's a square root, little index of 2 here, we're looking for a pair, right? And I do have a pair right there. So that number comes out. So it's 2 comes out, and what's left inside is a 5. So root 20 is the same as 2 root 5. Hopefully you remember that. We did that a lot last year. So we have 4 plus or minus 2 root 5. And that's the answer. Couldn't get the answer here, but we sure got it there. So the square root method's a good method. Alright, here's some more of square root method. We're not going to try factoring because most of these you can't factor. So remember, first thing you want to do, get this this part isolated, the squared part isolated. Easy. Take away 5 from both sides. So you end up with x minus 1 all squared equals 1 take away 5 is negative 4. Now we have it isolated. We're ready to take the square root of both sides, plus minus. So on the left hand side, we're going to be left with x minus 1. And on the right hand side, the square root of negative 4. What? Oh, you can't take the square root of negative 4. That's not possible. So in other words, the answer is that. No solution you could write. Or you could just put the no solution sign if you want. That'll happen sometimes. There's no number you can put into this x so that this left hand side will equal 1. It's impossible. Okay, we need to isolate the squared part on this next question. Now be careful. You know what's squared here? It's not 2x. What's squared here is just x. If 2x was squared, it would look like this, and you'd have to isolate the 2x. But in this case, the only thing that's the only thing that's squared is the x. So you just need to isolate the x. So let's do that. Take away 4 first of all. You're left with 2x squared equals 10. Now I need to divide by 2 to isolate the x squared. So x squared equals 5. I'm ready to take the square root of both sides, remembering to put plus minus. So my final answer is x equals plus or minus 5. If I can simplify this radical, I should. What multiplies to get 5? Just 5 and 1. No, there's no pair there, so this is already in simplest form. Okay, let's try a few questions that are a little bit more difficult. So remember, our strategy here is we want to isolate the squared part. And the part that's squared here is all the stuff in brackets. We got to get rid of this 9. Since the 9 is multiplying all this, we'll divide both sides by 9. And when you do that, you're left with x minus 1 squared on the left-hand side. and you're left with 13 divided by 9. Now, I'd really appreciate it if you didn't write that as a decimal. Don't put it in your calculator. Just write 13 divided by 9. 13 over 9 is a fraction. Okay, we've done it now. We've isolated the squared bit. So now we can take the square root of both sides, remembering to put plus or minus in this one. Okay, on the left-hand side now we have x minus 1, and on the right-hand side we have plus or minus the square root of 13 over 9. But if you have the square root of a fraction, it's the same as the square root of the top number divided by the square root of the bottom number. And don't forget to put plus minus out front here. Now, why did we do this? Because if you take a look at the denominator here, we have the square root of 9, which is great. That just equals 3. So we're going to be able to simplify this. All right, let's move this negative 1 over. We've got to add 1 to both sides, right? So the negative 1 comes over, becomes plus 1. Then we have plus or minus square root of 13. Can we make a tree and simplify 13? No, you only get 1 in 13. So you're stuck with the square root of 13. But on the bottom, you don't have to put square root of 9. Square root of 9 is 3. And there you go. There's a great answer. Now, there actually is one more step you can take. I won't insist on it, but if you want to make it look even nicer, what you could do is get just a single denominator. Put it all over the same denominator. Put it all over 3. Now, in order to do that, think of this 1 as being 1 over 1. Since we want it to have a denominator of 3, what do you have to do? You have to multiply bottom by 3, and you have to do the same to the top. You have to multiply the top by 3. So you end up getting 3 plus or minus the square root of 13, all divided by 3. This is great. Love this answer. If you want to stop in this previous step here, I'm okay with that. But if you can go to this one here, I think it looks a little bit nicer. Okay, this looks ugly. We got fractions in here, but you still follow the same rules. You want to get the squared bit isolated. The squared bit is all this here. So we need to move this negative 3 over 16 to the other side. So we have x minus 1 over 4 all squared equals 3 over 16 when it moves over. Okay, now we're ready to take the square root of both sides. Make sure you put plus minus. And if you do that, what you'll be left with over here is x minus 1 over 4. And on this side, again, let's do plus or minus the square root of 3 over the square root of 16. And again, this is a nice move because square root of 16 is equal to 4. We can't simplify the square root of 3, but we can turn this into 4. Okay, so we're going to move the negative 1 over 4 over and it becomes positive 1 over 4 plus or minus the square root of 3. There's nothing we can do to that. All over the square root of 16 is 4. Hey, look, if we want to make this last step, it's really easy here because we already have the same denominators. So all you have to do is put it all over 4 and just write 1 plus or minus the square root of 3, and that's all over 4. Again, I like this answer. I love this answer. So this is the one that gets my circle status here. Okay, next, why did I put this one here? Oh yeah, I know why. So we want to get the squared bit isolated. The only thing squared is that m, not the 3m, just the m. So you got to get the m isolated. To do that, we'll first of all move the 8 over. Going to add 8, right, to both sides. So you get 3m squared equals 8. We still need to get rid of this 3. Since it's 3 times, we'll do the opposite. We'll divide. So you get m squared equals 8 over 3. Now you're ready to take the square root of both sides. When you take the square root of this side, make sure to put plus minus. And what you're left with is m equals, again, let's turn this giant radical here with the fraction in. Let's turn it into one radical sign on the top, one radical sign on the bottom. Okay, now if we look at this, it's not as nice as the last two we've done because you can't take the square root of 3. So what are we going to do here? Well, there's a couple things we can do. We'd like to try to simplify both of these radicals, and we also want to rationalize the denominator. We don't want a radical in the bottom. I think it's easy to actually simplify first. So you can't simplify 3. If you do a tree for 3, the only thing you get is 1 and 3, and that doesn't help us. But we can simplify 8. If you do a tree for 8, you get 4 and 2, and then 4 goes to 2 and 2, and we're looking for a pair. Here's a pair. So that comes out, and this 2 stays in. You get 2 root 2. So just let me rewrite that. We have m equals plus or minus 2 root 2 over root 3. Great. Now both radicals are simplified, the root 2 and the root 3. There's nothing else you can do. But we don't want a radical sign on the bottom. We have to rationalize this denominator. So what we do to rationalize is we multiply the bottom by root 3, and we multiply the top by root 3. So this will be our final answer right here. M equals, let's look at the bottom first. Root 3 times root 3 is 3. On the top, plus or minus, 2 root 2 times root 3. Well, you multiply the numbers inside the radical together. So root 2 times root 3 is root 6. You still have the 2 up front. So 2 root 6 over 3. Can we simplify this 6 and this 3, cross them out? No, because this one's in a radical and this one's not in a radical. In order to simplify them, they either have to be both in a radical or both outside a radical. These numbers are both outside a radical, but you can't simplify them. So this is it. This is your answer. Plus or minus 2 root 6 over 3. Two answers, right? 2 root 6 over 3 is one answer. Negative 2 root 6 over 3 is the other answer. Okay, last one. They're getting pretty similar to each other, aren't they? I hope you're catching on here. So we need to isolate this bit. First thing we need to do is take away 3. So you get 2x minus 1 all squared is equal to 9. Now we've isolated, we can take the square root of both sides and put plus minus. So on the left hand side we're left with 2x minus 1. On the right hand side, hey, this is really nice. The square root of 9 is 3. So we're left with plus or minus 3. Okay, here's why I showed you this question here. The next step we have to do in order to isolate this x is we have to add 1 to both sides. And what a lot of people do, so obviously on this side what's left is 2x. What a lot of people do, don't write this, is they put, well, 3 plus 1 is 4, so now you have plus or minus 4. You can't do that. This is a plus or minus, so those are much different numbers. I'll show you in a second why this doesn't work. But basically what you want to do when you add the 1 on this side is put 1 plus or minus the 3 that was already there, and that's the way you'd write that. How come? Why did I have to do it that way? Well, remember I said what a lot of people do here is they just put plus or minus 4. Let's see if this is true. 1 plus 3 is 4, so that works out nice because positive 4. 1 minus 3 is negative 2. Hey, that didn't work. The other number we said was negative 4. Do you see how that just doesn't work? So you have to write it this way. Okay, last step is to divide both sides by 2. So what you're left with is x equals 1 plus or minus 3 all divided by 2. Now, this is correct, but we can simplify this. I mean, why leave it like this? We can actually figure out what that's equal to. We have two answers here. One answer is 1 plus 3 divided by 2, and the other answer is 1 minus 3 divided by 2. Why don't we figure out what both of those equals? 1 plus 3 is 4 divided by 2, which means x is 2. There's one answer. 1 take away 3 is negative 2 divided by 2. That means x is negative 1. There's our other answer. So we have two answers here. If you're able to actually, get a whole number or integer value, you should do it. You shouldn't leave it in this form like this if you don't have to. Of course you have to leave it in that form when you're dealing with something like this question up here, because we don't know how much root 3 is. But down here, we know how much 3 is, so you can add 1 plus 3 and 1 minus 3. Alright, I hope that makes sense and I didn't talk too long there. It was getting a little bit long-winded. Take care.